Today's the big morning. Yesterday we ordered the steel to fabricate the pieces that are joining this house together. It's been raining quite a bit in Victoria Falls, and so it's sort of been difficult to set the concrete. So we've dug 5 holes basically that make up the main sort of supports for the house, and in the hole we've set up stones, mesh, some more mesh, and then some deformed bars or rebar that's tied, that's going to make up the main concrete structure. Then on top of that, our 5 triangles will sit and will be interconnected to make up the icosahedron shape. You know, it's it's really scary when you're now doing the thing that you've just seen as drawings and little matchstick figures. But it should be exciting. We're hoping to move into the house before Christmas, but I think I'll just be happy to get the structure up, so that we can just get a full appreciation of what we're trying to achieve with this project. So it goes. Montage. Okay. This is everything in our design. It's an equilateral triangle, which makes up the shape of our house. The shape is called an icosahedron, or a geodesic one frequency. So one frequency because geodesic shapes are usually made up of a series of triangles joined up together to make up a dome, and so they come in different frequencies. So the one frequency has only one type of triangle. Then you've got 2 frequency, 3 frequency geodesics, and so on, which have more different. They've got different shapes and different sizes of triangle. We wanted something that was going to be very simple to build, and so the way that the building system works is that we take a triangle that's made up of 3 pieces of, whether it's timber or whatever building material, steel, it could be gum poles, but later on we're looking into how we can recycle plastic to create a sort of unique, structurally sound construction material. So this is what we have initially, and so we have to figure out how we're going to join each of those poles together in a sturdy manner, which is where we then have that V shape that's there, which is like comes in at a 60-degree angle and joins up each of the sides of the triangle, and then what happens, so it holds it from the inside on all 3 sides. The entire basic shape then has 15 pieces, so that's basically 5 triangles, so 15, so 3 sides, and then those are joined together, and then we get our shape. Okay, so that's our little construction system. So the bottom parts would normally have been held by a similar shape cutting across here, a pole, but instead what we did is that we placed each of these corners onto a pier block, which is basically a concrete mix going into the ground, about 1.2 to 1.5 meters, and that basically holds each of these things in place. Because we're using 6 meter poles, it would mean that our ceiling or our roof would be unbelievably high. So this is why we've then taken the Tonga approach of making these the stilts of the house, and then the floor will be built sort of midway into this structure, so that we've got almost like a 2-meter clearance. This particular design then made it quite special because then we don't have to cut down any trees, and this could literally sit like above the tree line, and then the trees can then be exposed through the floorboards to grow as plants initially, and then a full-on tree in the house. So it's quite an interesting building method that we're going to be using. It's easy to put up and also easy to collapse. And that's also one of the advantages as well, because it sort of celebrates the nomadic nature of African architecture. And we're very keen on that kind of thing, of houses that move to allow for the land to heal and so on. So that's basically our what our hut is going to look like. And so instead of completing, because the icosahedron normally would have the same shaped items coming from the ceiling level to make up the roof. Instead, what we've done is we've gone for a lower pitch on the roof by using trusses. So I can't remember what the trusses are called when they sort of come halfway. So they sort of come halfway and then they're held together by a compression ring, something similar to Mongolian architecture of the yurt. So there's a compression ring that holds that in place, because we've got a fireplace that's going directly in the middle of the house, sitting in the middle. That's probably just going to be for our sort of biogas. We want to utilize all of the waste from the house, so the biogas will be used for a little fireplace that's there, just to provide basic heating, to heat up water and that kind of thing. So isn't she lovely? Isn't she wonderful?
Driver is going to pick up the steel from Steel, and then we'll take it to Mr. Dube so he can start the fabrication. Yeah. And then I'll go with Mr. Mzizi tomorrow, so that I can to Mr. Dube.
Oh, okay.
So I can pay him.
Oh, okay.
Yeah. Or at least I don't know what. We'll see what we'll do.
Yeah.
and then after the fabrication, when I've done with Dube, I'll come back and then he will go to Mr. Fixit to go pick up the 2 cube river sand, the wheelbarrow, and
cement.
The cement.
Which one did you get?
The super set or something.
Super set, okay.
And the super set is the best one.
Okay.
But just remind me
the columns.
The columns, that's the one we said we need to discuss. If you tell me to go up still and go buy the metal, then that's what we'll do.
No, maybe let's do
that guy.
The 50.
Okay, so if that guy agrees to the 50, which would be great.
So we have to assemble the columns ourselves.
Yeah, it seems that way. Yeah.
Okay. How high are they? How high are they?
It says they're 2 point something.
2 point something meters.
Yeah.
Oh, so they're very high. So we have to somehow figure out how to get the cement inside.
Yeah. Okay. If he agrees to the $50.
No, I think our method is better of doing the steel thing ourselves. Because then we do a smaller column. So we don't have to do a lot of work lifting.
So tomorrow, do you want me to go to Upsteel and buy that column thing?
The steel?
Yeah.
I think so. But when you go there, tell them to fabricate it into the column. So I'll have to go. I can't do this because baboons. Okay, so no. I'll do the instruction to say I'll calculate, because it's 2.4 meters. So I need to know what the diameter, the circumference is going to be. So I'll ask for those columns to be made. They need to do a straight, like a weld, right down the.
So they're cutting it in half and then putting it together.
Yeah.
Okay. What is the thing called?
I have no idea.
Okay. All right. So that's fine. I can go buy those.
Because that way, if we get 2 out of them, and then that's okay for our construction needs.
So do you think it's 3 o'clock now? Maybe do you think I should have gone and bought them now? That way they would have all gone and been transported to
No, I still have to calculate.
So it doesn't matter. They fit in Mr. Talonga's car.
It might not. Anyway, we'll see. Yeah, they will. They will, because they're 1.2 meters across.
To
They're
transport.
1.2 meters across, so I can fit them in the car. Yeah.
Okay.
So either way, I think what we're going to do is pour the concrete at the bottom for the first part.
Okay. Because he's already got the wheelbarrow, so he's got it.
Yeah, then we'll do the second part.
So remind me, Panapa, remind me to carry.
Okay, we're here to get some of the steel for the construction of the, I think for the actual foundations. So I'm here just getting a tour of what each item is because I don't know what any of the things are. Is taking us around to show us some steel stuff for some of us who don't know, and those of you who are following can also learn a bit or two. Wow.
So you've got this which is written deformed bars.
Right.
This is our deformed bars section.
So which one are we
And
taking?
this is the size that we
This is the
checked. This is 12 millimeter deformed bar.
Okay.
And on our flat bars,
Yeah.
there is a 100 by 8 millimeter flat bar,
Okay.
which is this one.
This one. So this is holding up the house. Okay. Oh, this is why you need that. Is this the thickest one that's possible?
Yes.
Okay. Excelente.